Good day, everybody. How are you all? This is Dr. Nandi. Today we are going to talk about dependent samples, t-test. So I'll share my computer screen with you. Says 10 individuals went on a low-fat diet for 12 weeks to lower their cholesterol level. Do you think the cholesterol levels after 12 weeks are significantly lower? Use alpha equal to 0.05. So there are two columns of data. Same individual, we have start cholesterol level and end cholesterol level for same 10 individuals. At the beginning, their cholesterol level, and at the end of the 12-week period, their cholesterol level. Since the information is collected on the same individuals at the beginning of the test period, 12 weeks, and at the end of the test period, which is 12 weeks. So at the beginning and at the end, at the start, at the end, same individuals. Therefore, this is a two sample dependent. Dependent, why dependent? Because the same individuals, we depend on the same individuals at the beginning and at the end to collect the information. So this is solution. Since cholesterol level is measured on the same 10 individuals at the start and at the end. This is a two sample dependent t-test. Okay. So first thing we will do is press the stat button in the calculator. Then number 1, which is edit, and enter start data. Oh, let me use that. Enter start data. So start data in L1. Data in L1. Okay, so but before you do that, you have to clear the memories of the calculator. So maybe I'll erase all of that. So I want to erase all of that because first I need to clear the memories of the calculator. So I cannot jump to this step without clearing the memories of the calculator. So first thing to do is press second button, then plus button, which is on top of the enter button on the bottom right corner. Then select number 4, enter. You will get clear all list on your calculator screen. Then again enter, and then done. So second plus bottom on top of enter button, then number 4, clear all list on the calculator screen, then enter, done. Then stat 1. Now we are ready to, so let me create some space. Okay, so next thing we do is stat button, then 1, number 1. So stat 1 and enter information, start data in L1. Okay, enter start cholesterol level in L1. Okay. Oops, sorry about that. So go back. Oops, I didn't go. Oh boy. Okay, back again. Okay, enter start cholesterol level in L1. Okay, so let's do that. 140, then 210. Sorry. Let me give the thing, move the thing a little bit down. Let me move the thing a little bit down. Okay. So 140, then 220, then 110, then 240, then 200, then 180, then 190, then 360, then 280, and 260. Okay. 140, 220, 110, 240, 200, 180, 190, 360, 280, and 260. Then the right cursor key. Okay. So now I'll move this a little bit up so that, okay, I can write a little bit. Then right cursor key, right cursor key, first line in L2, list 2 actually, and enter end cholesterol data, end cholesterol data in L2, data in L2. Okay, so right cursor key, first line in L2, okay, and then cholesterol data in L2. So what are the numbers? 140 in L2, then 230, then 120, then 220, then 190, 190, okay, then 150, then 200, then 300, then 300, and then 240. Okay, so let's check 140, then 230, then 120, 220, 190, 150, 200, 300, 300, and 240. So we have entered data in L1 and L2. Now let's move this quite a bit up because we are ready to do the tests now. Okay. So just do you think the cholesterol levels after the weeks, after the 12 weeks are significantly lower? Significantly lower. Okay. So let 1 is equal to cholesterol level at the start, and 2 is equal to cholesterol level. So let me write this carefully and clearly. This is 1 and 2 is equal to cholesterol level after 12 weeks. 12 weeks. So as per the suggested hypothesis test, HA is mu1 greater than mu2 and H0 could be mu1 less equal to mu2. Now this translates to H0 mu1 minus mu2 less equal to 0 and HA is mu1 minus mu2 greater than 0. Now let's create some more space. These are two sample dependent test. So here let mu1 minus mu2 is represented by mu d, is difference in population means. In population means. So our null hypothesis is mu d less equal to 0, alternate is mu d greater than 0. Okay. Okay. So now in the calculator, in TI-84, right cursor key, press the right cursor key to move the cursor to the first line in L3. Okay. Then use this one or up cursor key to move the cursor to where L3 is written. Okay. And at the bottom left of the calculator, you will see L3 equal to. Now here you're going to type second one means L1 minus second two means L2 in L3. Okay. So second one minus second two and hit enter. Okay. So your L3 is now filled with L1 minus L2. Okay. So we will do hypothesis test. We will do t-test on L3. Okay, so press the stat button. Then test. Stat, then highlight test on the top row. Then scroll down to t-test and hit enter. Enter. Input. So input should now be on data because we will do the test on L3. Input is on data. Bring the cursor on data and hit enter so that it's flashing on data. Mu0 is the hypothesized difference is 0. Okay. So mu0 is 0. Is the hypothesized difference in the two population means, which in the null hypothesis is 0. In two population means. Okay. List is, you have to change it to L3. How do you do that? Second button and then 3. Okay. So list is L3, second and 3. Frequency is 1. Alternates. Okay. So frequency is 1. What is my alternate? Mu. Okay. So if I just move this a little bit, you will see the alternate is mu d is greater than 0. So alternate mu is greater than mu 0. So bring the cursor on greater than mu 0 and hit enter. And then go to calculate. And hit enter. And hit enter. So look at the test statistic. Is 1.173. That means the sample mean difference is greater than the hypothesized value of hypothesized value of 0. So the sample mean difference of these 10 differences is greater than the hypothesized value of 0 by 1.173 times the standard deviation of the sampling distribution, okay, of the means. And look at the p-value. P-value is equal to 0.135. So p-value is the probability of getting a test statistic as extreme as 1.173. So alpha is given as 0.05. P greater than alpha. Decision, do not reject H0. Do not reject H0. Okay. Conclusion, at alpha equal to 0.05, there is no evidence to support the alternate hypothesis. Evidence to support H, which is, if you remember, mu d is greater than 0, right? So let me write it over here. Okay. So there's a second way of doing it like before. So let's do it this way now. So I will basically create some space and change the color of the key to blue. Yep. It's the second way of doing it. Second way. Calculate the 95% confidence interval for mu d. Okay. So what will you do? Stat button, then highlight test on the top row. Stat, then test on the top row, then scroll down to t interval. Okay, hit enter. Input should be data. So it should be flashing on data. If it is not, bring the cursor on data. List is L3. Frequency is 1. Remember, list is L3, right? Frequency is 1. Sea level is 0.95. And calculate. And the 95% confidence interval for mu d is minus 8.3 to 26.3. So if I do a number line, 0 is somewhere over here, minus 8.3 is over here, and 26.3 is over here. And this is the confidence interval. So if I create some space and write since the hypothesized value of 0 is inside the 95% confidence interval, we do not reject H0, which states mu d is equal to 0. Okay, and conclude at alpha equal to 0.05, there is not enough evidence to support HA, which is mu d greater than 0. Okay, we do not reject, same decision as before. Do not reject H0, mu d equal to 0. So I'll stop here today. Again, for the second method, 0, the hypothesized value of the mu d in the null hypothesis, 0 is inside the 95% confidence interval. Why 95%? Because level of significance is 0.05. Therefore, we decide or make the decision do not reject H0 at alpha equal to 0.05 and conclude that at alpha equal to 0.05, there is not enough evidence to support the alternate, which states that mu d is greater than 0. Again, the hypothesized value of 0 is inside the 95% confidence interval. Hence, we do not reject H0. I'll stop here today. If you have any question, comment, you can write me a note. I'll get back to you as soon as possible. If you like this video, please share it with your friends. I'll appreciate that. And if you like this video, please give me a thumbs up. And please, you and your friends, subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'll come back next time with another interesting problem, interesting solution. Take care. Have a nice day. See you next time. Ooh, I don't want that.